Hey,
Hello.
Moon. How's it going?
I'm good, thank you. How are you, Laura?
Doing well, thanks.
Glad to hear it. And thank you all so much for joining us live. If you're watching this not live, hello as well. I'm off to a start today. Yeah, hope everybody's having a wonderful day. Here we are doing some more Wasm learning. This is going to be a great time. And yeah, um, how are you feeling, Laura? How are you feeling about our journey so far?
I have honestly just been having so much fun, you
I'm
know?
glad.
Yeah. And I really like being able to follow all the little rabbit holes.
Hmm.
Yep.
I think it's one of the best ways to learn, honestly. So,
Hmm.
folks, if you're watching live, this is not just me and Laura pairing. This is ensemble programming. So please chime in, give your opinions, give your suggestions. Um, tell us what rabbit hole we're going down next. Like, please, we're here to learn together.
Yes.
Cool. So to catch everybody up on what we've been doing so far, Laura and I have been making the Conway's Game of Life tutorial with Rust and
Can we grab a
WebAssembly.
link? Sorry. Can we have a link for that in the chat?
Oh my goodness. Yes, of course. Thank you for the reminder. Wasm Game of Life. That was, uh-oh. I need the link again. Excuse me for a second. In the meantime, Laura, I've been mostly driving the last two sessions, but today we made a pull request, and Laura will be very kindly driving today. I will be navigating, and of course, y'all in the chat will be ensembling.
Hmm.
And while I very strategically waffled my way through that, I got the link back. So
Yay.
let's see where we are rendering. So we got our Yeah. So we last time we managed to render our game of life as a string, which you will find
Mhm.
in this link that I've just posted in here, and I'll send it to you in the private chat as well, Laura. So you have a link.
I got it from the chat.
Wonderful. And yeah, so we managed to render that as a string in our JavaScript, which was good.
Hmm.
But today, what we're going to be doing is moving along and rendering that as an HTML canvas,
Hmm.
which I think is going to be exciting.
Yeah. All right. Let's see. Sharing.
So yeah, we'll be sharing our screen shortly, and
Yep.
then we'll be thank you very much. So here we go. Let me just put us nicely there in the corner. So I made a pull request to your
Hmm.
repo.
Right.
I take it that you've merged that and
I have.
pulled already. Fantastic. So we are
Oh, pulled. I have not pulled.
ah
There we go.
great.
Awesome.
Oh, sorry. Could you make that a bit larger, Laura?
Yes. Thank you for reminding
Please.
me. Is that,
Wonderful.
how's that?
That looks good for me, folks in the chat. As always, I defer to you. So if it looks too big or too small, all you got to do is let us know, please. Um, cool. I'll just get us out of the way there. No such file. Do you know what? So you've done git branch set upstream to origin, and then there's some branch in bigger than and smaller than.
Oh, yeah. I forgot to change that.
So we need to do that to main.
Oh.
Yeah. Could you do me a favor and do a git status, please? Mm-hmm. So the following untracked working tree files would be overwritten by merge. Okay,
That's fine, right?
that's okay. So we're gonna do that by removing them. If you
Okay.
trust me, Laura, could you do
I agree.
actually without the git? Could you
Oh,
do an rmrf?
Sure.
Sorry, rm-rf.
Yeah.
Yeah. And then put in the www. And now we can do a git pull and see how that goes. Excellent.
Right. Okay. Where were we?
Awesome. So we are up to date. Oh, could you make this bigger too, please?
Yes. How's that?
And that's fantastic. So that last part where you see that game of life there, that's where we were last week.
Mm-hmm.
So next we're going to be rendering to canvas directly from memory.
All right.
Yeah, so what we've been doing so far, generating and allocating a string in Rust, and then having Wasm bindgen, which you remember is that sort of bridge between Rust and Wasm.
Yeah, I kind of think of it as the translator.
I like that. Yeah, I think translator or compiler I think is a good metaphor for that.
Mm-hmm.
And then having converted to a valid JavaScript string makes unnecessary copies of the universe's cells. As the JavaScript code already knows the width and height of the universe and can read WebAssembly's linear memory that make up the cells directly, we'll modify the render method to return a pointer to the start of the cells array. Okay. What's a pointer in this context would mean we're returning the render method returns the entire universe as a string.
Mm-hmm.
And what we're going to do instead is modify it to return a pointer to the start of the cells array. Pointer in this case being like a Rust pointer, so a pointer to the place in memory where they're stored.
Right.
Also, sorry.
No, go ahead.
Did you wanna ask me something about that?
Nope. I'm all good.
Okay, cool. Also, instead of rendering Unicode text, we'll switch to using the Canvas API. We will use this design in the rest of the tutorial. Inside Wasm Game of Life www.index.html, let's replace the pre we added earlier with a canvas.
Okay. So this in here in line 21. Okay. Okay, so this is actually replacing the entire body, not just... There we go. Okay. So, Canvas. I haven't used Canvas before. Do you want to tell me about Canvas?
Absolutely. So Canvas is, in short, I believe a new element added in HTML5 that what it does is allow us to draw 2D graphics. Provides a means for drawing graphics via JavaScript and the HTML Canvas element. Amongst other things, it can be used for animation, game graphics, data visualization, photo manipulation, and real-time video processing.
Nice. All right.
Yeah. So that means that we'll be, instead of drawing a string into a pre, we will be drawing it into a canvas with 2D graphics instead.
Nice.
So to get the necessary information from the Rust implementation, we'll need to add some more getter functions for a universe's width, height, and pointers to its cells array. All of these are exposed to JavaScript as well. Make these additions to Wasm Game of Life source librs. So we're going to be adding. Are you familiar with getter functions?
No. Is it related to like a get method, HTTP method?
Ooh, I'd say kinda.
Okay.
I mean, get is one of the 5 HTTP methods. I think there are 5. Get, put, post, delete, and patch. Get, put, post, delete, and patch. If only I'd known how to do that in university, I would have done a lot better. Sorry. uh, right. In this context, a getter function is something where we've got a box. Like we've got let's treat a module as a box. And these are functions that are purely dedicated to getting something from inside of that box. Say we're putting our hand without looking into the box and being like, okay, I'm going to get this, get that thing.
Okay.
So what these three functions are doing is saying like, I need a function to be able to get the width of the universe, the height, and the cells, respectively. Okay. I hope I didn't completely butcher that.
Nope. Well, if you did, I wouldn't know, but it sounded good. Made sense.
I mean, if it made sense, then that's already a great victory for me.
Yep, I liked it.
I'm glad. Cool. So you'll see that we will add this as public methods exported to JavaScript. So we've got on line 23 of our code, we've got a Wasm bindgen. So remember, we use this Wasm bindgen. I don't know if it's a macro. I forget the names. This Wasm bindgen declaration to say, hey, expose this to Wasm, please.
Right.
So that, not to Wasm, make it publicly accessible within Wasm so that JavaScript can interact with this universe struct. But from line 30 onwards, we've got unexposed implemented functions like get index, live neighbor count. These are not exposed to JavaScript. However, in line 53 onwards, we've got that Wasm bindgen again. We've got new, render, and tick, which are all exposed. So we'll be adding these three more to be exposed.
All right.
Excellent. So we've got three there. One will return the width of the universe as a U32. The other one will return the height as a U32. Oh, do it one line below that.
Yeah.
No, sorry, you're still inside the new function.
Oh, am I?
Yeah, sorry. If you make a new line between 73 and 74, then you're good.
There we go.
No, sorry, you're still inside the new function. There's that closing bracket on line 73. We want to be outside that. Nice. Excellent. Cool. So we've added those three functions which expose the width, the height, and the cells as PTR. That's Rusty's for this as a pointer, as opposed to giving a whole, like instead of giving all of the cells as a bunch, being like, here's all the cells, we're instead telling Wasm, hey, that's where they are. Does that make sense?
Yeah. Specifically, it's where the first one is. Is that right? I think I read that. A pointer to the start of the cells array.
Yeah, exactly. So instead of passing around now 64 by 64 pieces of data, we're instead just being like one. Right. Which makes it like lightweight. Awesome. So next we're going to go into our JavaScript where we will also import the cell enum and define some constants that we'll use when rendering to the canvas. Because of course, one of the things that we exposed in our lib source is the cell enum. Do you remember the cell enum?
I think so.
It's that data type that has two possible values, alive and dead.
Right.
And we can define as many as we want. Like another thing we could have done is have a Boolean for true and false, like alive and dead. Sorry, alive, true or false. Right. However, by using an enum and giving these values ones and zeros, we were then being able to add up all of the alive neighbors.
Right.
So that's what made it clever.
Yep, that's handy. So we need to add this cell.
So we're going to be importing
what we're importing. Oh, sorry, go ahead.
You're totally fine. And we're going to define some constants. So we're going to define a cell size in pixels, a grid color, a dead color, and an alive color. Ah, of course. And we've got our custom universe sizing. Remember from last time?
Yeah. That's right.
Cool. Next, let's rewrite the rest of this JavaScript code to no longer write to the pre's text content, but instead to draw to the canvas. Now, the first 3 lines, const universe, const width, and const height, should be okay. We already have a universe. And technically, because we define our width and height when starting up the app, we don't really need to query the universe for it. Do you know what I mean?
Yeah. So we don't need this line 6 basically because lines 4 and 5 are going to take care of that.
Kind of. You see, in lines 4 and 5, we've asked the user for a width and a height. Then in line 6, we use that width and height from lines 4 and 5 to create a universe.
Right. Oh, yeah. Okay.
What the code here on the left is doing is saying creating a new universe, remember, with its hard-coded 64 by 64 width and height, and then asking that universe, hey, universe, what is your width and height?
Right.
But I'm wondering, do we need to do that? Do we need to query the universe for its width and height if we already know what they are from lines 4 and 5?
Right. Yeah. I mean, I shouldn't think so.
Yeah.
I guess we can try not querying it and seeing if it works.
Sounds good to me. So then let's remove line 3 because we're not going to be using the pre element anymore.
Right.
Oh, actually, instead of removing it, sorry, could you know what? Ignore me, Laura. I'm so sorry. Please delete it. I'm a mess today. Thank you. Thank you for putting up with me. Of
course.
You're very kind. So after that, after our alive color, let's create a variable called canvas, which will be the element with ID game of life canvas. Right. So there we're saying like, hey, get me that element that has this ID, which we just now changed from being a pre-element to a canvas.
Right.
Next we're going to define the width and height of the canvas element itself. And we'll do that with our cell size constant, which we define. You can see it on line 6. So it'll be 5 pixels plus 1 times the height plus 1. I guess that's to give it a little bit of padding around the sides. Right. So we're saying like, hey, set the height to be 5 times height plus 1.
So I wonder why. I guess it's that like, why are we hard coding things? Question again, because here we're defining the cell size to be 5, and then here we're referring to the cell size instead of just putting 5. Or so, in this case 6.
So in my opinion, that would be so that when we as developers later on want to tweak that, we only have to do so in one place.
Sure.
I think that's the long and short of it.
That makes sense.
Yeah. Cool. And then we're going to get, const ctx is equals to canvas get context. So this is, sorry.
No, go ahead.
So I think what we're going to do here, let me look this up. Canvas context. I'm going to look this up real quick. Because I think that's the graphical context that we're going to be drawing in. Let me see if I got this. To get a canvas's 2D rendering context, call get context on the canvas element, supplying 2D as the argument.
Mhm.
And then once we will use that context to do the actual drawing in the canvas.
Yeah. I'm curious about what these other I'm in a rabbit hole, sorry. I'm
All
curious
right.
about what the other arguments, potential, like, okay, so what if you don't say 2D? What else can you say?
So I think WebGL, from my experience, is an implication of 3D.
What does GL stand for? Oh, my rabbit
Graphics
hole has a
layer.
rabbit hole. Ah, okay. That makes sense.
It's based on an existing one called OpenGL, which
Mhm.
is cool because, and actually that's a great rabbit hole because that goes into one of the applications of WebAssembly that I know, which
Mm.
is that since OpenGL, I'm about to get this completely wrong. So if you're in the chat and you think Ramon is completely wrong, please speak up. Otherwise, this will live on as incorrect information, and I apologize. But since OpenGL is related to WebGL, these are standards for drawing graphics. It is possible to port, let's say, C code for OpenGL to WebAssembly with WebGL.
Okay.
What that means is that 3D graphics that were rendered in OpenGL, say old computer games, one of the earliest cases of one of the uses, one of the earliest applications of WebAssembly that I know is, I think there was a game called Quake 3 that was quite popular in the late 90s and early 2000s that
Mhm.
got ported from OpenGL to WebGL, and
Ah.
so it's playable in the browser, essentially,
Ah, very nice.
from what I understand.
Cool.
So yeah, we're going to be grabbing that context to do our actual drawing.
Okay.
And then inside the render loop, we're going to call universe.tick. That we already know. And below that, we're going to draw the grid and draw the cells. So we will need to remove line 7. Yep,
This.
exactly. And then we've got two functions there, draw grid and draw cells, which aren't defined. And that's because we're going to have to define these functions ourselves. If you
Oh boy.
scroll down a little bit, you'll see to draw the grid between cells, we draw a set of equally spaced horizontal lines. So we will do the grid first.
Okay.
Now, here I would recommend that we be lazy, we copy paste, and we go through the code. Does that sound okay to you?
Absolutely.
Fantastic. And we can put that, I would say, I would put that in line 15.
Okay.
Because we're doing quite a few things here. So this CTX, you remember, is the context.
Yes.
So we've defined a function called drawGrid that starts out by calling begin path. And there it's saying like, hey, start drawing. Then we say stroke style is grid color, which is I think all C's is going to be a light gray.
Okay.
So we're making a light, we're going to say, hey, everything you draw is going to be light gray.
Mm-hmm.
Then we're going to be, so we're going to loop through the number of columns, because vertical lines. We're going to move to the top, and we're going to move, think of it as moving a paintbrush programmatically. So we're going to move the paintbrush to the top, and then we're going to say that's moving without painting. So we're just like moving with the brush lifted. And then we're going to line 2. That's where we supply an X and a Y coordinate to paint all the way down.
Excuse
Bless
me.
you. Bless you. Sorry, I don't know if you sorry. I hope I didn't talk while you missed it.
Oh, I'm good.
Yeah,
Yeah, my ears and my nose can work at the same time.
just making sure. I'm really sorry.
No
Um, yeah, so what we're doing here is just painting each line programmatically.
Mm-hmm.
Paint, paint, paint. You didn't by any chance ever use was it logo in school?
No, not logo.
That was like a little drawing tool that I used when I was a kid, which was like for telling a turtle to programmatically to run around and draw a picture, and it can make like very cool patterns.
Oh, okay. The turtle sounds really familiar.
Yeah,
Maybe I just didn't remember the name.
I
Okay.
think Logo was the name of the programming language. That's another rabbit hole in of itself.
Ooh.
Logo and pedagogy for programming.
Mm-hmm.
Sorry. So so what we're doing here is programmatically drawing each vertical line, and then we're
Mm-hmm.
doing the same with horizontal lines.
Right.
And then we call stroke, which is to just it's kind of like printing it onto it's kind of like printing all the stuff we painted onto the canvas.
Okay. So in lines 22 to 24, so we're determining where the vertical lines are going to go, but we're not actually putting them there yet.
Yeah, it's like making a I'm making a mess of this and I apologize.
No
In my
problem.
head I picture it like a printing press.
Yeah.
Right?
Right.
We're
Mm-hmm.
defining what that pattern is going to look like.
Mm-hmm. Okay. Yeah.
With-
And then we
with-
do the same. We determine where all of the vertical lines are going to go,
yeah.
but we haven't put them there yet. And then we determine where all the horizontal lines are going to go, but we haven't put them there yet. And then in line 32 with the stroke, we're stamping that printing press.
Yeah.
Yeah.
Exactly.
Okay.
And then
Cool.
and then when we call stroke, that's when it actually we put on the ink with the stroke style that we determine, and then put it on the canvas. In fact, if you're feeling bold, Laura,
Always.
do you want to try and see if it paints the canvas for us? The
Sure.
the grid?
Mm-hmm.
In that case, let's comment out line 40 because we're not going to draw the cells yet. Awesome. Yeah, and let's get our app going.
Where are we? We're on 8080, is it?
Yes. Do you have it running?
Oh no, sorry.
All good.
Getting ahead of myself.
Don't apologize. You're fine. Yeah, so we need to first build the Wasm,
Mm-hmm.
and then we need to run the HTTP.
Yeah. Okay. I don't remember the commands for that.
I think it was Wasm pack. So Wasm dash. Oh, actually, if this is the same computer, Laura,
Mhm.
we might have it stored in our terminal history. You want to try with Control R?
Sure.
And now to start typing Wasm dash pack. There it is. Now you can hit enter.
Excellent. That's super handy.
It's such a great tool.
Yeah. I think Jagger told me about this a couple of weeks ago, and then I forgot.
It's not that you forgot. I always say this. It's not that you forgot. It's that you got exposed to it.
Mm-hmm. Mm-hmm.
So that next time you see it again, you're like, oh yeah, I think there was something like this, and
yep.
Then it enters the common use.
Mm-hmm.
It's taking
the
a
longer
while,
term memory.
Yeah, exactly. I'm a bit suspicious that it's taking a while. Do you maybe want to try hitting enter again? Okay, just making sure. Maybe it's starting up. But yeah, so what we'd be doing, actually, you know what we could do in the meantime? if you don't mind my being impatient,
Not at all.
is set up our speaking of impatient, is set up our never mind, we're good. So let's cd now into www and set up the web server. So we'll need to do npm install. Perfect. And with that done, we should be good to go. Because we've done everything. We've done, yeah. So we can do npm run, is it start?
I think so. Yay.
Good news.
And is it 8080? Where is it? Yeah, 8080.
Nice. Yes.
That's right. With our default 64, we can just stick with that for the moment. Yay! We have our grid stamped.
That's pretty great.
Yeah.
I would. Do you want to just experiment with it just a little bit and make it maybe a? Oh, Laura, there's no need for us to zoom in
because we could just make it bigger.
We can just set the cell size to be bigger.
All right. So let's see. I'm gonna zoom back out.
I think you had it at 150.
Yeah.
So what's 150% of 5? What's 7.5?
7.5.
Which I don't know if we can do that in pixels.
Can
we call it an even 8? Yeah. Nice. Right, we need to put those in again.
Yay.
And see, because this is what I love, is that essentially we're just drawing, which is super cool. All right, well, let's there's our grid. I would say let's move on to drawing our cells next.
So we can uncomment our cells.
Perfect. Now that's going to appear empty, and you know what? Oh, never mind. Yeah. So actually, I believe if you right-click and go to the JavaScript console, you'll see an error.
Right-click anywhere?
Yeah. And then go on inspect. If you go to console, the tabs at the top. There, uncut reference error, draw cells is not defined at render loop.
Right, because we did our draw grid, but we didn't do our draw cells.
Exactly. So that's what we're going to be doing next. So we can directly access. Sorry.
Oh, there it is. It didn't immediately say draw cells. I was like, oh no.
No, that's because we're doing a couple things here. So we can directly access WebAssembly's linear memory via memory, which is defined in the raw Wasm module, Wasm Game of Life BG. BG? Background? I don't know what BG stands for. Binary game. No, I have no idea.
Where even is that?
Yeah. We would find it in PKG at the very top.
Okay.
And it's one of these. Maybe we can expand it a little bit. Oh, there it is.
This is it.
So I guess one of the things we're exporting here is called memory. Do you maybe want to see if you can look in this file for something called export? And check it out. See? Oh, look at that. There's something so cool about seeing our code turned into something else.
Yeah.
So there's our cells, And there's our universe. There's 20 of these. Let's see what else we got. There's universe. Now remember, folks, if you're watching, this is the generated WebAssembly JavaScript, essentially. Wasm bindgen. That's it! As I said it out loud, BG is bindgen.
Of course, that makes sense.
Right. So we're going to be able to access that memory. Let's see if you don't mind if we keep going and see if we find something called memory here, right?
Sure.
Thank you. WBG buffer. Export. That's looking better.
The very last one.
So yeah, that's got to be it.
Mm-hmm.
Right. Because what we're doing in Wasm is kind of building our own memory.
Mm-hmm.
So what we're going to be able to do is, because remember we've got that pointer that we want to access.
Mm-hmm.
So we wouldn't be getting a copy of the cells. We're going to be accessing the pointer to that very first cell inside the Wasm.
Right.
If that makes sense.
Mm-hmm.
Cool. Let's use it then.
All right. So we were in
index. Yeah.
Okay, so we need to come up here, import our memory. Oop.
Yeah, and you'll notice that we're not importing from Wasm Game of Life, but from Wasm Game of Life / Wasm Game of Life BG. So we're very specifically going into our package and saying, get it from this module here, which is the Wasm bindgen.
Mm-hmm.
And next we're going to define two functions, one of which looks pretty familiar, the get index.
Yes.
Right, because since we're accessing that memory, we're not getting that 2D matrix. We're getting that one-dimensional array. So we're going to need to be able to one-dimensional array. We're going to need to be able to get that
wrong. There we go.
All good.
Key mappings all over the place. Sorry, I totally interrupted you.
No, you didn't. You're totally fine. Yeah, we're essentially getting we're pointing to that one-dimensional array. So if we want to be able to access a specific cell by row and column, we need to essentially port this function over.
Sorry, I'm slow. I don't type on this keyboard super often.
Take your time.
So it gets way slow.
we got nowhere
to
go.
No. Really raises the top one.
There.
Okay.
So one thing I would ask you to put in is after the second equal sign, we need a bigger than.
Oops. I thought I had that.
I think it was there for a second, but I think it might have been deleted. Perfect. Now it's an arrow function. So there we can return, and that's that formula for getting a cell at a specific row and column. Perfect. Nice. And next we're going to be doing some more context stuff in our drawcells function.
Okay.
Do we want to copy it over like before?
Yeah.
And step through it?
That would make sense.
Cool. So what do we got here? So we got a function called drawcells. Doesn't return any. It doesn't take any parameters. In line 41, we're getting a pointer to that first universe cell.
Mm-hmm.
Next, we've got line 42. What do we got here? A new uint8 array memory.buffer cells ptr, which is the value returned from line pointer 1, width times height. Okay, I believe we're making an array here. A uint8 array sounds like a byte array. Uint8 array. I will put in a link into the chat. So uint8 array typed array represents an array of 8-bit unsigned integers. The contents are initialized to 0. Once established, you can reference elements in the array using the object's methods or using standard array index syntax. So first is the buffer, the memory. The first parameter is the memory buffer. The second one is that right?
Second one is the pointer, right?
Yeah. When called on a buffer and optionally a byte offset and a length, the byte offset, so the second one, the cells PTR, and length parameters, which is the third parameter, specify the memory range that will be exposed to the typed array view. If both are omitted, all of the buffer is viewed. If only the length is omitted, the remainder of the buffer is viewed. So from my understanding, what we're doing is telling it very specifically, hey, take this memory for this many, and put this many bytes of it into this array.
Okay.
Cool.
That makes sense.
Awesome. Essentially populating, essentially taking all of that memory and dumping it. Essentially what we're doing is taking that array, that memory, and dumping it into an array of our cells.
Okay.
Yeah. So
now why do we need to do that when we're drawing the cells, but we don't need to do that when we're drawing the grid?
That's because it's a good question. Why do we need to do that when drawing the cells, and why don't we need to do that when drawing the grid? What information do we need for drawing the grid? We need to know the width and the height. Right? The width and the height are either defined by us, or if they're not, they're exposed as those public height and width functions.
Right.
Now, what information do we need to draw the cells? We need to have the state of every cell.
Okay. Right, because that's going to determine whether we're filling in the cell or leaving it empty.
Exactly.
Okay.
So the difference here is that we need access to an array of cells.
Okay.
And we could copy it over from Wasm, from the Wasm memory. Which would, if we want to do, we could have Wasm create a copy for us. Or we can access it directly from Wasm, which is what we're doing here.
Right.
This is where that memory intensivity. Do you know what I mean?
Intensity?
Yes, that's it. Thank you. That's it. Sorry.
No worries.
It's where that memory intensity comes into question, where we can say, listen, why copy all of that data from one memory buffer, which is this virtual Wasm one, into the JavaScript heap? Whereas what we're doing here is just saying like, hey, let's just take all that data and work with it. Does that make sense?
Yeah.
Cool.
Works for me.
Okay, so in line 44, we begin drawing like we did before. And then we do a loop through the rows and columns.
Right.
We get the index for that row and column. And then we do a fill style we're saying, hey, context, your fill style shall be, depending on whether the cell is alive or dead, the color, dead color or alive color.
Right.
If we scroll up to what dead and alive colors are, we'll see that the dead color is white and the alive color is black. Or is that the
Okay.
other way around? No, if it's all Fs, it's white. Yeah.
Right.
And if it's all zeros, it's black. So right. So if a cell is alive, then it'll be colored white. Black. And if it's dead, it'll be colored white.
Right.
And there
right, because we can't actually just leave it empty. Right. We have to say, in this case, empty is white.
Oh, good point. Yeah, because every time we draw a frame, if we draw nothing, it'll have the same state as last time.
Mm-hmm.
So if a cell was alive before, then it was black. If we don't paint it next time we draw, it'll stay black.
Right.
So literally what we're doing is wiping the whole canvas clean and then starting over.
Mm-hmm.
That's a good point. And there we're seeing, and you'll see that we get cells at index we're checking that it's equals to cell.dead. So we're using that cell enum value in line 50.
Mm-hmm.
And then finally, what we're doing in line 54 is drawing a rectangle at these coordinates. So the x coordinate would be column times cell size plus 1 plus 1. The y coordinate be row times cell size plus 1 plus 1.
Mm-hmm.
And then the width and the height of a rectangle that we will draw.
Right.
Which is cell
which
size.
we determined in cell size.
Which would make it a square.
Mm-hmm.
And then we call cell.stroke. Context.stroke, which...
Stamp.
Exactly.
Yep.
How does that sound?
Sounds good to me.
Cool. Shall we save and try?
Yeah.
We got a whole bunch. I think we got some errors. Draw cells is not defined. Const draw
Did
cell.
I not successfully save this?
Actually, what's giving me a bit of a suspicion is the fact that it says connection refused. Could it be the server's not running?
I don't know.
Shall we hop on over to the terminal and see?
Uh-oh.
Oh, cell size is empty? Let's scroll up to the top again, please. No, I think we need to scroll further down in the terminal and see what's up. Yeah, keep going all the way down and see what the latest error is. There, npm, it stopped. There we can see abort. So if we run npm run start again, we might be able to see what's up. That sounds good.
Yeah.
And if we refresh, we might get some even better news. Hey, look at that.
Yay!
So this is now drawn on an HTML canvas, which is cool. We're not copying over an entire string over from Rust, which is cool. We're literally just accessing that pointer of data.
Yep. I actually can't look at it.
Oh, it's giving you a headache.
Yeah, it's funny.
Oh, dear. Is it the colors or the speed?
I don't know. I don't think it was happening last time.
No, I don't remember happening. I'm sorry.
Anyway, I'm assuming it looks cool.
Sorry, I'm thinking because I wonder if we can slow it down.
Oh,
that might help.
A speed?
That's
Like
what
a
I'm
tick?
wondering.
How long the ticks are? Would that be it?
Yeah, feel free to feel free to switch tabs if that helps. Cool. Let's scroll down in our code. Let's go down this rabbit hole because I'd love to know. See, this request animation frame is what's giving me suspicion because, yeah, we're requesting a new animation frame.
Mhm.
So what if we can say, hey, don't draw yourself. I have a terrible idea.
Okay.
No, actually, never mind. That terrible idea didn't even work. I was thinking of having a parameter for this called draw yourself, where if it's true, it draws, and then it calls request animation frame with it set to false. Well, to set to the opposite of draw yourself, so that it would only draw half the time.
Okay.
But that doesn't quite work. So
Mm.
request animation frame, set speed, maybe? Controlling FPS, okay. Let's see what we got. FPS interval, animate the sounds. The problem throwing constant update. I'm very sorry. This isn't very entertaining. I'm just trying to think like,
No worries.
okay, an idea that comes to mind, which is not very elegant, is to use something called JavaScript set timeout.
Mm. Okay.
So what we can do is yeah. Let's add a line between 72 and 73.
Okay.
And let's call in set timeout. So that's SE, like exactly, timeout. Now this function takes this function takes two parameters. One is a function, and the other one is a number of milliseconds.
Okay.
So let's put in an arrow function here. So we would do brackets, like empty brackets.
Mm-hmm.
That would be smooth brackets, not square ones. Sorry, the regular brackets, like the ones you have here. Perfect.
Friends.
Parentheses, that's it. Thank you. And then an arrow, the equal sign and the bigger than.
What did I do? There we go. So the what's happening behind the scenes here is I have a Moonlander keyboard, and most of my keys have no labels on them, and they're like 4 layers deep, and I keep pressing the wrong layer switching button. So
I can very much relate, having an empty Ergodox myself.
Yep. Okay.
It's a lot of fun muscle memory stuff.
Yes.
It's really a testament to how weirdly the brain interacts with memory.
Yep. And I've been working mostly on the MacBook in the last couple of weeks, and so I've like lost all of the. Anyway, sorry.
I totally feel you. Don't apologize. Like, cool. Now we need our curly brackets.
Mm-hmm.
Now let's put a comma after that closing. Yeah. And let's put in amount of milliseconds. What do you think is an appropriate amount of milliseconds?
I couldn't say, so I think we're just gonna have to experiment.
Yeah, let's say 10.
Okay.
Cool. And then inside those curly brackets, let's add an enter.
Enter?
Mm-hmm.
Oh, right. Gotcha.
And in there, let's copy paste request animation frame, or cut and paste rather. So every 10 seconds, sorry, every 10 milliseconds, we will call that. Yeah. So let's give that a save and then see how it looks. And it'll probably take some experimentation. So I apologize in advance if it's still no good to look at.
I can look at it for a second and then look away. So it's
Still too fast.
better, but it's still not awesome. I'm going to try 100.
I was going to say, let's make it even slower.
Yeah, that's better. It's I have like lingering headache from before, and so it's hard to say at this point whether it's all good or whether it's still not so much. But it's definitely better.
I'm sorry. I'm very sorry, Laura. I think my I think my computer there we go. Just had a small moment of slowing down. So this is better? I heard what you said, but I couldn't reply.
Yeah, it's definitely better. I've still got like a little bit of lingering headache from before, but I don't think that it would be caused at this point.
Okay.
So I think
then awesome. All right. Well, now we've got that all working.
Mm-hmm.
Shall we see? Yeah. Wasm build, npm run start. We've done all that.
Mm-hmm.
As an aside, there's also a really neat algorithm for implementing called hashlife. It uses cool. Definitely a rabbit hole worth going into sometime.
Exponentially faster. Future generations, the longer it runs. How would you even see that? Like, it's so fast already. How would you even detect? I wonder faster?
I wonder if this is where something like an older computer or like a less powerful machine might notice this, or a mobile device.
Okay.
Might find this like no, I'm still not done unpacking, but I have this old, not actually old. I have this KaiOS phone, which it uses it doesn't have a touch screen, but rather uses physical buttons, but it still has a modern browser in it. I think it runs on Firefox. I could be wrong. Where the hardware isn't so good. They're quite popular in other parts of the world, and that's where having this kind of exponential performance gain might be beneficial.
That makes sense.
Yeah. Cool. Well, I think, shall we take a look at what the exercises are out of curiosity? Yeah. Initialize the universe with a single spaceship. Instead of hard coding the initial universe, generate a random one where each cell has a 50-50 chance of being alive or dead. Did we do that in the end? With the random stuff?
I feel like we did.
Yeah.
We did that ourselves.
Yeah. Representing each cell with a byte makes it easy, but it comes at a cost of wasting memory. Each byte is 8 bits, but we only really require a single bit to represent whether each cell is alive or dead. Refactor the data representation so that each cell uses only a single bit of space. Interesting. I'm afraid we're out of time for today. So I don't know. What do you think? Do we want to take a look at the answer, or is this something we want to maybe take a look at next time we have a go at this?
Well, let's see. So what do we have left to do in here? Oh, we have testing. So we do have stuff to do left.
Yeah.
So we're definitely going to be doing another one of these. Let's do this, the memory thing at the beginning of next time.
Sounds good. Cool. Well, thank you so much, Laura. That was a joy as always.
Yes, thank you.
I learned a lot. I really appreciate it.
Likewise. So much learning.
Cool. Well, folks, thank you so much for watching. If you ever want to see anything in particular, if you ever have any comments, please feel free to leave a comment here on YouTube, or if not, join us on our chat. Do I have it here? I do not. I should have put it on. Chat.suborbital.dev. Like, come talk to us about streaming stuff if you want to. If you have ideas for stuff you'd like to pair on, anything like that. Like, we're here to do this together.
Absolutely.
Cool. Well then, until next time, folks, have a good one and enjoy the rest of your day. Thanks again, Laura.
Thanks, Ramon. Bye.
Bye.